Okay. Just to get us started so that we don't have to spend a lot of time reviewing some algebra skills that you need throughout Unit 1. We have just a few topics that we will review so that it's kind of fresh in your head. These are things that you've seen before, both probably in Algebra 1 and Algebra 2. Couple of things that you'll need in terms of skills throughout Unit 1 is being able to solve both linear equations and inequalities, solving what we call literal equations, and then solving a system of equations. So the first skill that we will look at is solving both linear equations and inequalities, just for a single variable. So if we look at the first example, anytime we see a bracket or a parenthesis, we know that that indicates multiplication. So the first thing that we will do, work all the way inside out. I'm going to go ahead and distribute the 2, bring everything else down. I know you guys are getting up into some higher levels, but don't be too proud to still show some work so you don't make some silly mistakes. So this is going to be plus 8.6 minus 2x, and then we can go ahead and distribute this negative throughout that quantity. And then we'll go through any like terms that we might have we can combine. On the right-hand side, I have 2 in the 0.8. And then over on the left, let's first go ahead and just distribute that negative through. And then from there, we can again combine like terms. I have a couple of like terms here with the 3, negative 5.4, negative 8.6. So 3 minus 5.4 minus 8.6 gives me a negative 11 plus 2x equals our right-hand side. And then from here, it's just a matter of getting our variable terms to one side, constants on the other. I will go ahead and add that negative 0.3x, and then add the 11 to the other side as well. And then we can divide both sides by that 2.3. And we actually end up with a nice 6. If we look at the second example, what I would suggest on something like this, where one of your terms is written as a fraction, go ahead and make the other terms a fraction as well. Because what happens is that there are some common mistakes that happen here when only one term is that fraction. From here, we can actually clear our denominator by multiplying through everything by 3. So if I do that, and again, I'm multiplying by 3 over 1, so only those numerators really get multiplied. So this will give me a 9t. And then because I have that denominator of 3 in that middle term, the denominators actually cancel out. So I'm just going to have that minus 2 times the quantity t minus 1 equals, and then that would be 12. So I'm multiplying everything, every term by 3, but because that middle term has a denominator of 3, that cancels out, which is then leaving us with just a pretty basic linear equation here. From here, distribute the negative 2. And then combine like terms. I'm going to go ahead and move that 2 over as well. And we can leave our answer as an exact 10 over 7. And then number 3 is a linear inequality, just the difference of having an inequality sign versus an equal sign. Same type of thing here, move variable terms to one side, constants to the other. So in doing that, I get -7 is less than or equal to 0.5t. I can divide both sides by that 0.5, and that gives me -14 is less than or equal to t. Okay. The next skill that we are going to need for just Unit 1, first of all, is solving literal equations and inequalities. So a literal equation is an equation that involves many variables, and what you're going to be told is which variable to solve for. So if you look at example 1, it says to solve ax plus by equals c, solve for y. So our goal is to get that variable y all by itself, everything else on the other side. So the first thing that we have to do here, we are going to subtract that entire term ax. That leaves me with the term that involves the variable I want isolated. So subtracting ax over gives me c minus ax on the right, by on the other side. And then from there, to get y by itself, I'm just going to divide everything by b. So that gives me the quantity c minus ax all over b. If I have y by itself, I've done what I needed to do. On number 2, we have a literal inequality, and this time we are told to solve for x. So I want this term, first of all, by itself, so I'm going to move that k over by subtracting. And then from there, to get x by itself, I'm just going to divide both sides by a. Oh, shoot. You know what I just realized? There's an x over there. Let's go back. Scratch that out. Sorry. All right. I did not see that there's an x in that term. Okay. So what we need to do in this example, because we have that variable x in both of these terms, we are going to group the terms with the variable we're solving for. So what I mean by that is we are going to actually put ax and bx on the same side, and then we're going to put k on the other side. So actually, let's go ahead and subtract ax from both sides. So sorry about that. So if I subtract ax to the other side, I get k is greater than or equal to bx minus ax. Now, once you have those terms with that variable you're solving for on one side, then what you're going to do is factor out that variable. So what I mean by that is I'm going to factor out a GCF, which is x, from both of those terms. That leaves me with b minus a. So k is greater than or equal to x times the quantity b minus a. Now I can divide by this entire quantity b minus a to get x by itself. Sorry about that, beginning. All right, so we have k over the quantity b minus a is greater than or equal to x. The next example is similar in terms of kind of grouping the terms with the variable together. So in this case, I'm solving for q. So I have this term with a q, and then I have a q there as well. But before we kind of move things around, let's go ahead and distribute the r and the 4. Just kind of simplify this up a little bit. Okay, so I have p squared q minus rq minus r equals 4p plus 4r. Okay, so at this point, since I'm solving for q, I'm going to keep that term as well as that term on one side, I'm going to move the negative r over. So when I add that r over, I get p squared q minus rq equals 4p plus 5r. So again, we're solving for q. I have those two terms on one side. Now I can factor out the q and then divide both sides by that quantity that's left over. There is nothing more that we can simplify or cancel there. You cannot take an r out of both of those terms. Algebraically, that's incorrect. So not the prettiest or most simplified answer. It is most simplified, but not the prettiest answer, I should say. But you do have q by itself. All right, the last skill that we need to just kind of refresh for getting us started here is solving a system of equations. This is something that you guys are usually pretty good with. You do in Algebra 1 quite a bit, Algebra 2. You can use any method it says, so either substitution or elimination would be your best bet. So if we look at the first example, before we really try to do anything with this, let's go ahead and simplify these two equations up a little bit. For the first one, I always like to clear my fractions. So if we multiply that first equation through by 2, that gives me 2y plus x equals 6, just so we don't have that fraction. In the second equation, let's distribute that 2 and then kind of move like terms over. So I'm going to move that y over to the left, so this is written in standard form. Okay. From here, I would probably use elimination just because these are both written in standard form. I can go ahead and bring the 2x plus 3y equals 1 down. Now, when I bring this first equation down, I'm going to go ahead and switch the x and the 2y just so that my variables are lined up in my elimination. From here, we can multiply the second equation by a negative 2. And then I'll just bring that first equation down. And now the x's are eliminated. From here, I have a negative y equals negative 11. So y equals positive 11. And then from there, we can take that value of y, substitute it back into either of our two equations. It does not matter. I'll just pick the first one. So 2 times 11 plus x equals 6. 22 plus x equals 6, and subtract your 22. We write the solution to a system as an ordered pair because really what this solution is giving us is the coordinates of the point where these two lines cross. All right, last example. Notice in this last example that both of these equations are actually written in slope-intercept form where you have y equals already by itself. So let's do this. So if y is equal to this quantity and y is also equal to this quantity, then this must be equal to that. So let's go ahead and basically we're substituting that quantity in for that y. So we can say that 3 minus 2/3 x equals negative 4 plus 3 halves x. So at this point, we're basically back to just solving a linear equation. If you want to clear your fractions, as we've done in a couple other examples, we can multiply through by 6. So just watch when you multiply that through, make sure you're not getting stuck on these fractions. So this would be 18 minus 4x equals negative 24 plus 9x. From here, just group your variables on one side, constants on the other. So this gives me 42 equals 13x. So x is equal to 42 over 13. We can take that value of x, substitute it back in, again, either one of these equations to find y. And I'll just choose the first one here. All right, so we got some fractions over here. You can have your calculator help you out a little bit if you would like to. So what we need to do first is multiply 2/3 by 42 over 13. You could do that on your calculator. Just put parentheses around your two fractions. And then when you hit enter, it will give you a decimal, but if you hit, some of you are going to know this, math, which is right underneath your alpha button, and then option number 1 will turn it back into a fraction for you. And it's not only a fraction, but it's actually the simplified fraction as well. And then from there, you can go ahead and do 3 minus that fraction. And then again, math number 1, hit enter, and then it will give you the simplified fraction that you need. So we should have 42 over 13 and 11 over 13.